Now. Thank you for coming. Let me introduce you to Valerio Velardo. He's an expert in the AI field, working on it for years, not now that is a hype and you see it in newspapers and everything. So we invited him in the frame of the UPF-BMAT chair, Music and AI. And today he's going to talk a bit about his experience, first-hand experience. He's the founder of Transparent AI, if I'm not wrong. Transparent Audio, sorry. And he has a presentation today to share with us about a journey through AI and music. I don't have the full title, but I will let him go through it. So it's about 35 minutes presentation. The idea is that you have a clear idea of what's going on, where do we come from, where we're going with all this. AI will be a disruptor for sure in the music industry. This is something we are already seeing in many phases and forms. And afterwards, we will have the opportunity to open the mic for you to ask questions. He has a lot of knowledge, both technically, also in the part of legal part as well, because he works with how to tackle all the legal complexities with the ecosystem, the music sector. And so you will have the opportunity to share your questions.
Okay, you guys, so thanks a lot for having me here. Thanks a lot, Gonzalo. And thanks a lot, obviously, Emilio. So today I'm going to talk about a little bit about generative music with artificial intelligence. We're going to talk about some of its history, some of the challenges, and what's going to come next. This is going to be a very informal talk, and the idea is just to give you some of the information here, because it's its own world here. A lot of things have happened over the last 2 years, but really over the last 70 years in this field. And so I'm going to give you a flash about all of that. But really what I want to do is just give you some initial thoughts, and then we're going to open the mic, and then as Gonzalo said, we're going to talk about the latest things. You can ask questions, you can comment, and let's keep it super interactive that way. Does that sound like a plan? Good. Okay, so this is me in a nutshell. So I'm the co-founder of Transparent Audio. This is a startup company that's doing AI transparency compliance for generative audio. And I collaborate with MTG, Music Technology Group, and obviously you guys know what that research lab is. And I have a course there on Gen AI music. How surprising, right? And as well. Good. So this is an overview of what we're going to be touching upon today. So first of all, difference between intelligent and creative tasks. So what's the difference between those two things, right? And that's the difference between AI and computational creativity, as we'll see. Then what's generative music, a brief history of generative music, and a bunch of different steps and milestones of it. And then we're going to be jumping into some random, or not necessarily super random, examples of generative music systems. Some of the current challenges that we still have, even though there's been a lot of evolution over the last few years. And finally, we're going to talk about how AI is transforming the music industry. Okay, so let me start with this picture. So what kind of task is this, would you say? What's that? Object recognition, right. And object recognition is one of those tasks that's quite objective, isn't it? So it's a little bit like this, right? So it's speech to text, right? And these type of tasks, they do have an objective success metric, right? So you either catch the word that I'm saying correctly, or you don't. Of course, there are gray areas, but in theory, more or less, they tend to be quite objective. There's a ground truth there. There's a ground truth for speech to text, and there's definitely a ground truth for object recognition. And they are well-defined problems, meaning that you can basically formalize them, and they are quite objective and they're well-defined. It's not like very ambiguous or subjective stuff. Now, compare that with this. A symphony, for example, writing a symphony, music for orchestra or for rock music, whatever you want, or this. Painting. Yeah, are there like objective success metrics for those two? Tasks? No. This is one difference. And then, are they well-defined problems, would you say? So, making music or painting? No. Yeah, and that's really the difference between artificial intelligence and computational creativity, right? Have you ever heard this word, computational creativity? So it's basically artificial intelligence, but for creative tasks, really. And computational creativity is that field, it's a subfield of AI where we teach machines to do things that we deem as creative, right? And so there's no success metric there necessarily, because we don't have the perfect equation for understanding whether or not a piano trio is a great piano trio or it's some garbage there, right? And so yeah, computational creativity is all about having machines thinking creative stuff and creating creative stuff. In our case, it's generative music. And so we do this to generate music. Okay, so generative music, it's its own subfield of computational creativity. So the whole thing goes from AI, computational creativity, and generative music as a subset or as a subfield of computational creativity. But really, this is a highly interdisciplinary field. And indeed, these are all the things like that get into generative music. So if you want to work like in this field, obviously you have to know about AI, you have to know about music information retrieval, DSP, digital audio, digital signal processing, obviously software engineering. There's a lot of researchers who are like good at research, but they suck at software engineering and they're completely useless, especially like in a startup setting, because they're not developers or software engineers. Music cognition is also like another one like that. If you have, is a great boost. And music theory, because we derive a lot of like the ideas like that we implement in generative music from music theory, musicology. Cool. Okay. So what are some of the challenges that we have in generative music? So what are some of the challenges when we try to teach machines how to create music by themselves? So there you have like a few of those. So how can we define, represent music, right? This is a very hard problem, not just in MIR, so in the analytical side of things, but also in generative music. How can we evaluate generated music? Who does the evaluation? Is it the lay person out there that we can get like here out in the square? So we propose to this person just like some random music that we generated, or is it musicologists, or perhaps it's musicians, or perhaps it's the users who are going to be using like that model that we've developed, right? So this is a very, very hard problem, and obviously it's not solved. And then we have another important question. So who should, how can we evaluate generated music, and who should evaluate generated music? Yeah, so these are like the two things, because you may know who you want to have like this music evaluated by, but then how do you do that? Is it a technical thing, or is it more, oh yeah, this is the overall vibe that I have like from this generated music, and that's good, that's bad, or should I get into the details of that? So these are important problems that, again, have not been resolved and probably will never be resolved, and this is one of the really cool things when you work with ill-defined problems and machines, that there's always another day, there's always another challenge, and you're never going to be done with that. Cool. So I'm going to give you like some ideas on how to classify some of these models, generative music models. And yeah, you can ask some simple questions. So what's the goal of the system? There are different goals. There are different, a gazillion use cases out there, right? So some of these systems generate melodies, others can generate chord sequences, some, and I'm sure like you would know some of these systems already, would generate like full tracks, like Suno, Udio, right? Are you guys like familiar with those tools? Yeah. And others like may generate jazz improvisations or loops or sounds, like the list goes on and on. And the goal of the system is not just about like the use case itself, but also for what Do we generate music for video games, perhaps for movies, perhaps for art, or perhaps that's absolute like concert music, right? So in this way, like you can have an idea of how to classify like these different systems. And there are a gazillion systems like in a bunch of different categories in a sense. Then another way of classifying the systems is who uses these systems, right? So it could be songwriters, it could be composers, it could be developers of a video game. They need some music in real time, and then they may have an AI music generator that does that for them. Or it could be researchers, right? Or consumers, users, like audio users, for example, or Suno users. How's music generated? So this is also like another important question. So by sort of like going through all of these questions, you can get an idea of like the type of systems like that you are dealing. And yeah, and as I said, like there are a lot of different systems. We're going to be looking at some of these and take a look at how, at the different use cases or possibilities out there. But again, the sky's the limit here. Cool. Let's move on. Oh, yeah. And how's music represented, right? So this is a key question. And there are mainly two high-level ways of representing music. Are you guys like familiar with this, like symbolic and raw audio? Is everybody familiar with this? Cool. Yeah, we're going to go through this like super quick then. So symbolic music representation is quite straightforward. It's basically like a score, so by the way, like you get like bonus points like if you recognize like this first 4 bars. What's that? Beethoven fifths. Yeah. Yeah. Ta 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 dim, ta 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 dum. Cool. So that's basically the idea, right? So you have symbols on a page, or it could be a page, it could be like in digits, it really doesn't matter, but the idea is that you have symbols that represent audio, but you don't have audio directly, right? And, well, it could be a score, like a Western music score, like Beethoven, Mahler, Stravinsky, or it could be a piano roll, and this would be like your, I don't know, like everybody doing like music production these days. Like a piano roll, it's an XY like plane, right? On the x-axis, like you have time, on the y-axis, you have like pitch, right? And every event like there in green is an event, right? That has a certain pitch on the y-axis and a certain duration on the x-axis. Yeah, so these are symbols. So we have just symbols and we generate, we train our models like with symbols and we generate music with symbols. Some of other like symbolic music representations are MIDI. Of course, I guess like everybody here is familiar with that. Music XML and ABC notation, you just like name it. It's just like symbols that represent music rather than audio itself. Good. Raw audio representation, obviously like we're here at BMAT, so I don't need like to tell you like what this is, but obviously we're talking about waveforms. That's as simple as that. Okay, so when we do symbolic music generation, it's as simple as this. Of course, like it's not that simple, but you get the idea, right? So that's like the very, very high level idea. So you train a neural network or whatever model you may have in mind, not necessarily like deep learning. You train it like with symbolic music, and you get out at generation, at inference time, symbolic music. For raw audio music generation, obviously, what do? Well, you train your neural network like with audio. So these are just WAV files or MP3s, whatever like you want, really. And you're going to get back MP3s or WAV files at output time. Okay? Cool. Now, so that is the type of representation that we have like for the music. The other important question that we had earlier is like, how do we generate music, right? And across the history of generative music, we've used all sorts of AI techniques, right? So basically like the thing like went like this. There were like AI researchers, like the real researchers, like not us like doing generative music. They were like finding like new ways like of generating stuff or solving problems, and that could have been like with symbolic AI, machine learning, statistical methods, evolutionary algorithms. We would stay there, just like see what others were doing, stealing their work and applying like to music. As simple as that. We never invented anything. We just like stole. And we've been stealing like for a very long time, as you'll see. So some of these techniques are like symbolic AI. Are you guys like familiar with the concept of symbolic AI? It's also called good old-fashioned AI. So it's like rule-based expert systems. So before like the whole like machine learning, deep learning jazz, right? So these how things like were done like in the 80s, like in the 70s, and even before that. Then of course like we use machine learning, deep learning especially, over the last like decade, I would say more or less, statistical methods. Also like some kind of like very like generative systems like fractals, like cellular automata, and you would map music ideas like to some of these algorithms, like a cellular automaton, like the way like it develops like over time, like a cellular automaton, like you would map like different variables like to music, like for example pitch, rhythm, and you would get like some music. Well, it's not like the best music ever you can get, but still like it was a way like of automating the compositional process, and evolutionary algorithms, genetic algorithms, and so on and so forth. Now, of course I don't have time to get like into all the details. Like if you want those, you can either like read these two surveys. So that one, like the one on the left, is a great survey up until 2013. So it's all the old generative music stuff. And this has like state-of-the-art techniques, so machine learning and mainly like deep learning up to the end of 2023. So it's almost state-of-the-art. So you can read those two, or next year, like you can come to MTG and have like the Gen AI music course with me. So you guys like decide. Cool. So now let me give you an overview of like the different steps that I've identified in the history of generative music, right? So the first one, it's very, very long. It starts like in the 50s and it ends around like 2010. And I called it like the academic niche, and we'll see why that's the case. Then we have the first startup wave around 2010, I would say. Big tech experiments around 2016, and we have another one, but that's a surprise, and you'll see it later. Cool. So we said step number one, academic niche. So what's happening during this time? Well, there's a lot of experimentation. So all of these techniques, they were tried, used to generate music, and you would usually have incremental advancements. Nothing transformational, but tiny little bits of advancements, as usually like academic research goes, right? There's never like a huge jump in most cases, but just like incremental advancements. Then you would rarely get full piece generation. Rather than full pieces, you would get, I don't know, like a model that generates a melody, a model that generates a chord progression, a model that does like some harmonization. Rarely you would have like full tracks generated at once. No focus on audio production quality, mainly symbolic generation. And again, here we are in academia, so we don't care about products or quality, nothing of that, right? It was more about like the process itself and understanding how we could use all of these different AI techniques to generate like music. And then another thing like that made like this community move like quite slow was that it was super scattered. You would have like very few venues like conferences or journals, for example, very few of those. And the problem was like that there were people from across the board, from AI to music theory to music cognition to software engineering. So the community was very, very varied, but there wasn't a real unique venue where everybody like could meet. And this is one of the reasons why it took a lot of time like, to evolve. Okay, but this is, we believe, and that's a belief, the first piece of music generated by a machine. It's called the Iliac Suite. Have you ever heard of this? No? Okay, so you guys are listening to history here, really. So it's a string quartet, and it's divided into like 4 different movements, and each movement was, the generation of each movement was done with the different techniques. If I remember correctly, some expert systems, Markov chains, generative grammars, and it was done basically like to showcase different techniques and how they could be used like to generate music. So I guess like we can listen to a little bit of this. Okay. Yeah, you get an idea, right? So it's kind of like a fugato, kind of like with a lot of counterpoint, but with a lot of dissonances, because obviously we were in 1956, so your music, classical music was going like completely crazy, like with guys like Boulez and so on and so forth, and so these guys just like wanted to try like to imitate that, and they more or less like succeeded. By the way, like this was generated, symbols were generated, but then the actual like performance was done by human beings, by human musicians, which was super cool. Okay, so I guess we can move on. Yes. So second step, first startup wave around 2010, and here more or less like is the time when I personally like got into generative music myself. So what happened at this point? Well, there was a first wave of startup companies doing generative music, and you can think of this as adventurers, because like this was like completely uncharted territory, right? Generative AI wasn't a thing, right? So there were just like a few adventurers trying to open the way, and many did and many didn't, but they tried, and that's the important thing. So the focus spot sort of like moved from the research itself towards products. So now we want products that we want to sell, and we want for these products to be useful, hopefully for somebody. We moved from specific parts of a piece that got generated towards like full piece generation. And we had the first high quality generative music data sets, and so with this we could start using machine learning and deep learning. And we did, yeah, as a consequence, we used extensively machine learning for the first time. And these are some of the companies that were part of this initial venture. So my company was called Melodrive, and I'm going to talk a little bit more about that later. But then there were also like other like incredible companies like JukeTech. They were really the first ones, which was super cool. Amper Music, Ava, Mubert, Andal. Andal is still active today. They're doing really, really well. They're a Berlin-based company. They're great. And we're going to see them later on also. But again, this was like the first wave of startup companies to doing generative music. And let me tell you a little bit more about Melodrive. So we, with my co-founders, like we were three, but two of us like were just out of our PhDs. And so we decided, oh, you know what? We're just going to start a company, right? And we were both doing like generative AI music like during like our PhDs. And so we got out and we started Melodrive. And basically what we did was real-time video music generation, because generating music wasn't hard enough. So we had to do it in real time, and we had to change the overall like emotional intention of the music in real time, right? For video games. So if something happens, then the music is going to change. Because the idea was, yeah, video game music is great, but it's limited because, of course, like a composer isn't inside a video game. And so if things happen, the composer can't react to that. But what if we had an AI that can do that? And so that's basically the idea behind Melodrive. And so the music adapts to the emotional context of the video game, and we built an SDK for Unity. Are you guys like familiar with this piece of software, right? So the video game engine, Unity. So where like indie developers usually use that like for developing their games, and we sold it like to indie game developers. So this was Melodrive. Cool. So first startup wave sort of like vanishes around, I would say, like 2016, 17, and now we have new players entering the arena, and these are the big guns, big tech experiments. So what happens at this point? The focus shifts from more traditional kind of models and techniques and early machine learning and statistical methods towards deep learning. And why is that possible? Well, because these are big tech companies, and so they have access to huge, humongous data sets of music, and they have access to massive computational power, so they can train very complex neural networks on those data sets that they have. But the cool thing about these initial big tech experiments was that they really didn't have any commercial end goal. It was more about exploring what's possible with AI and using music and music creation as a sort of playground to see what's possible with artificial intelligence. And here we have a lot of examples. Magenta, so perhaps you guys are familiar with that. So Google developed basically an AI music suite, so with a lot of plugins, and you can still use them today in Ableton. They're quite cool. Some of this you can use to generate melodies. Others you already have your melody and you want to add a drum part or a bass part, and you can do that. It's quite cool technology. Then we have Amazon, IBM, Watson, and also OpenAI. We're going to take a look at two of these. One was called AWS Deep Composer, and it came out in 2019. So it was a model plus a little keyboard. Now, from my understanding of the time, this was never meant to be a product in itself. It was a sort of teaser for machine learning researchers and engineers so that they could see what's possible with AI, even generating music. So it was a sort of call for engineers and researchers to be creative with music. It was a quite cool piece of machinery. And then we have this, and this was really, really a turning point, I would say. So 2020, Jukebox, and this is the result of the work of OpenAI. So this was the first raw audio generation model that really, really was impressive. The result, we were mesmerized at the time because we were mainly dealing with symbolic music generation, and all of a sudden we heard this and we thought, oh yeah, well, this is just another level. It's a completely different level. And they were using VQ-VAE. Do you guys know what that is? Vector quantized autoencoders. Well, it's a type of neural network, right? It's a it's a flavor of neural network, and this model was able, and it's able, I guess, still to generate full tracks or snippets of music, and among the snippets you would also hear lead vocals in the style of a famous singer, for example. And it produces performance details, something that symbolic music generation could never do, because obviously you're dealing with symbols, not with the audio itself. So yeah, I guess we can jump to that link. And I think it's this one here. I'm going to show you feedback. Yeah.
No reindeer when it's rest away beyond the king of all the earth. And the baby at Christmas time, and on Christmas Day at Christmas time, on Christmas Day it's.
Okay, let's go back. Yeah, okay, you did. So who's singing this? Frank Sinatra, right? It was mind-blowing. Also, for us, researchers, and engineers, on the cutting edge, we heard this and we said, oh, what's this? So how did they, pull this one out, right? And I think, this remains one of the best models ever created, just because it's haunting, because it has all of those artifacts. So it's it doesn't really hit. It's a bit weird, and it makes it really interesting musically, right? Because it's that weird thing with a lot of artifacts that makes it so interesting. And yeah, it had these artifacts, and also you could hear something about Christmas, but really there weren't any words in there. So it was just Frank Sinatra mumbling gibberish stuff. And the neural network picked up perhaps Frank Sinatra or whomever talked, sang about Christmas so much that the neural network got that specific thing, but still, yeah, it was like impressive for us. But yeah, so some of the other things, yeah, this is a thinglet that we did with the Sound of AI community, like with my AI music community. Yeah, this was really cool. I just want to mention it because it was something different. We did it like in 2020 we started. We finished, I believe, like in 2022. So it was a community-driven research project with a lot of people from all over the world working. We built a neural synthesizer with voice commands before it was a thing. So we did like text to sound before it was a thing, really. And then like we published like this paper like at AIMT 2022, which is now the conference of reference like for generative music. So yeah, this was a cool project. If you guys like want to check it out, do it. It's quite cool. Everything is open source there. Right, so I was promising you that there was a final step like in this sort of like milestones, right? And stages in the history of generative music. And I call it the generative music hype. And it started around 2023, more or less. And why did it start? Because of this, right? Nobody cared about like what we were doing back in 2010 when I was doing like my PhD. Later on, when I was like co-founder of Melodrive, nobody cared about this, but now things have changed. We're living the generative AI revolution, and that started with this software here, right? This piece of software. So we are talking about 2022, like late 22, right? And then DALL-E 2, and a bunch of other text-to-image generation tools like came out. And so now all of a sudden, generative AI is a thing. So it's a thing for text, it's a thing for images, and obviously it is a thing for music and audio. And I think like this is the moment where things really change with the idea of like text-to-music generation. And in a nutshell, I think like you guys like are aware like these things and how they work, like it's Sune Audio, but at the time it was like quite, well, at the time it was like less than 2 years ago, but you get what I mean, right? It was like a novel thing. So you would write like an initial prompt, like that one, a fusion of reggaeton and electronic dance music with a spacey, otherworldly sound. You pass it through a music model and you get like some audio that more or less like sounds like your input. And sort of the first model that for me was like a turning point was this one here, Music LM by Google. It came out in 23, and really this was like the moment where we said, oh yeah, so this can be a product, also like at the level of audio generation, because by the way, like we don't generate symbols here, we directly generate audio starting from text. And I want to share one of the pieces that were generated with Music LM, and I guess like we have here. Okay, so I'm gonna read you the prompt. So the main soundtrack of an arcade game, it is fast-paced and upbeat with a catchy electric guitar riff, and so on and so forth. You can finish reading that. Okay. So let's go back here. So yeah, now all of a sudden we're entering a whole new territory that's a little bit higher fidelity, and well, we have all the basis potentially like for an actual product, right? Okay, so but Music LM wasn't the only model, text-to-music model developed and launched that year. It was a bunch of this, Muse AI, Audio, LDM, Sing-Song, Rave 2, Music Gen, that's part of a larger suite like called Audio Gen by Meta, and Refusion. I mean, all of a sudden we had a ton of models there, and we basically entered the Gen AI music revolution. That's like the way I call it, because like all of a sudden, like Gen AI music like was all over the place. It made the news because of like people using like AI like to clone like famous artists like vocals and music that was generated out of thin air, and then we had Suno, then we had audio. So all of a sudden, like generative AI music was all over the place. Cool. And just like to share like the feelings like that I had when all of this like happened. So I heard about like hundreds of millions, for example, invested like in a company like Suno, right? And back in the day when we were fundraising like for the same thing, we had to really fight super hard like to get our investments like from VCs, like with my company Melodrive. So all of a sudden like the momentum had shifted completely, and this wasn't like a few nerds like doing things that nobody understands. It was okay, this is like, these are the cool kids doing the cool kid things like in town. Cool. And that's part of like what I call the Gen AI music revolution. And out of like this revolution, a bunch of new companies emerged. Yeah, we already talked about Suno, Audio. There are companies all over the world, like India, for example, Beethoven AI, Kids AI, Deep Noise Music, Make It. The list could go on and on and on and on, right? Cool. So let me move towards the end of this presentation by talking about some of the challenges like that we still have in when we generate music. So some of these systems like Suno are quite impressive, but they still have huge problems with long-term structural music coherence. What that means is that they work really well, like when you analyze like 30 seconds of music, right? But then, or a section of music, but then if you go like to 3, 4, 5, 6, 7 minutes of music, it feels like a random walk. So this is still an open problem. Audio production quality has improved really quite a lot, but still it's not there yet. We're not at the level that, I mean, like a professional composer or producer could actually achieve. And then there's also like this other problem, that is we have, for the time being, for the most part, especially like for the Suno and Audio-like products, we have a solution in search of a problem rather than a problem in search of a solution, meaning that we still don't really have a product or a business case there, or at least it doesn't seem to be there yet. So it's a really cool tech, but we still don't know whether like that's going to pick up like as a successful product. That's usually like a problem that engineers have like when they work like with technology, right? We get like super interested in the technology that we completely overlook whether like somebody cares about like what we create, and we create it just like because it's cool. And then these are the problems that I think like it's becoming ever more important. So Matryoshka systems based on proprietary models. What does that mean? So if we take a look at Musica LM, and I'm gonna go back a little bit here, so you see that the overall model is really an overarching model that has a bunch of different sub-models in it, like Mulan, Soundstream, and these are huge foundation models, audio models. Like for example, Soundstream like is an encodec, right? So you pass like some audio into it in order like to get out like some embeddings that then you can use like for generation purposes. The point that I want to make is that these models rely on other like models that are extremely complex and costly like, to train, and these are proprietary. So even though like you may have like the whole thing, the whole infrastructure, and it may or may not be open source, but still you may not have access to the keys there, like these submodels that are necessary in order to get like the overall model, the overarching model like, to work. So you have like these matryoshkas where the different dolls at different sizes are proprietary, and so you can't really like, do anything with that. And so, and the sort of, the consequence of that is that smaller players like universities and smaller startups, like not the largest ones like Suno, for example, that are very well funded, can't really compete against large big tech companies. And of course, like this is not only true for generative music, this is a problem with AI in general. We are seeing a process of concentration of power, of data, and technology and computation in the hands of very, very few companies. And the problem is that this battle is fought on computation and data. And so large companies, big tech like Google, OpenAI, Amazon, Apple, and so on and so forth have an enormous advantage. And this opens up like problems that are, I mean, a societal risk. It's not just about music. It goes way beyond than that. Cool. So the last bit like that I want to quickly touch upon is how's generative music transforming music and who's generative music impacting. And the way I see it is that generative music is impacting listeners, musicians, and media creators, so everybody who's sort of participating in the music industry to an extent or to another. So let's take a quick look at generative music and listeners. So in this case, generative music can enhance the listening experience. So you have AI systems that generate music, and the music is consumed by listeners. And so this is like, for example, what we heard like with the iliac switch. So you have a system that generates something, and people listen to that thing. And yeah, I promised you I would talk about Endel, this like Berlin-based company. And this is like a really interesting application of AI-generated music, because like they don't really generate like music, but more like soundscapes. And yeah, you can read the tagline there, right? So personalized sound environments to help you focus, relax, and sleep. So that's basically the idea, right? So you want to code, and so you can put like some Endel soundtracks or soundscapes, really, or you want to relax, and you can do that. So it's a really, really interesting way of like creating like new soundscapes and music. So what should we expect in the future? Well, I think like the text-to-music models will get to social networks like TikTok, right? So everybody will be able to create like their own little bits like of music and customize music, as they can do like with videos these days. So they'll have a user-generated content with user-generated music as well. So I think like that's probably 1 or 2 years away. Personalized functional music based on mood, weather. So it's something like that responds like to some variables. It could be the weather, or it could be like your mood. And interactive albums and songs. We've always thought of songs as linear things, static things that we always hear like the same way. But it may well be the case that rather than having a song that's linear, you could have like a piece of interactive music. So you interact, it could be like a sort of like an app where you interact like with the app itself, and depending on some variables or depending on how you're navigating like the app, the music is going to slightly change. So moving on, generative music impacting musicians. Well, I think like here the sky's the limit, really. And it's a matter of human-machine interaction, but there are a ton of use cases. So inspiration, so you can use like some of these models to get some inspiration for a melody or a chord progression or a harmonization, enhancement, facilitation, collaboration, practice, education, you really name it. So I want to show you this one as an example of this human-machine interaction. And in this case, it's not just software, but a robo. And it's a very cute robo as such. How cute is that? No, they're just dancing. So it's just like choreography, machine choreography, right? Yeah, that's super cool. Yeah, and you don't need to have a full robo to practice with. You can also use software. Like for example, these guys here at Wave AI, they're doing like some really cool stuff. They have a couple of products. One is called Lyric Studio, another Melody Studio, and it's for songwriters. So you go there, and this software can help you like create like a song, and by that I mean it will help you with ideas for the lyrics as well as like for your melody and for your chord progressions. And this is cool because it's not you push a button and you get like the full song already done. No, it's more like an iterative process, and I think like this is gonna it's already happening, and it's gonna be ever more this way. So what to expect in the future? Yes, musicians will focus on high-level musical ideas. I believe that this will happen, and the details may be filled in by machines or AIs. AI music buddies like Simon will be a thing, and you can practice with them and perform with them as well. And composers will collaborate with AI tools to be more productive and get inspiration. I have a composer friend, for example, in Berlin, and already in 2017 or 18, he was using some of these tools, some of the startups of like that time, to get inspiration for quick music that he had like to churn super quickly, like add music for ads or music like for, I mean, I'm not talking about like absolute like concert music, like Beethoven level music, but just like to go through some of the tasks like that he had like faster, getting like ideas like from a machine. And finally, we have like generative music impacting media creators, and I think like this is also like quite cool. And we'll have AI tools which will generate music for media, and it will be for linear media, so for videos, movies, and ads. And this is something that we've already seen extensively. But the thing like that, well, my heart really is here with the interactive media, with the Melodrive idea like that I had like with my company, right? Because I think we could use a generative music to do things like that humans cannot do, like writing like music for interactive media. That's something that changes depending on how you move through a game, through a VR experience, or in a website, for example. And that's a unique experience that every user or gamer will have. Cool. So what to expect in the future for this particular line of attack? Well, AI takes over a composition of music for videos and ads. I believe that this is going to happen. For example, music for YouTube videos or music for ads. Obviously, there will always be like that high-end who wants to have like that super high-quality music, but like for the majority of media creators, probably like what an AI can do, like it is already okay. Then AI will enhance composers scoring interactive media. That's like what I was like discussing earlier, for example, for video games or for virtual reality experiences. And AI generated music for social media. I think like this is going to be a thing, especially like on networks like TikTok or Instagram. Cool. So I want to end on the promises of generative music, and I think like there are two levels here. So one is music democratization, so everyone can be a musician. Obviously, not everyone can be a musician, just like not everyone can be a photographer in the case of Instagram, right? But still, Instagram made it possible for people to express themselves creatively through photography, and in a sense, I assume that generative music will do something similar, but that doesn't mean that actual musicians will disappear. That's never gonna happen. But this is more for, let's say, like the lay person who can get like creative using AI. But for professionals or people who are more involved, at least like in music, I think like that AI will extend their capabilities, make them like sort of like streamline like their creative process, as well as like giving them tools that, or allowing them like to create music that otherwise like they just like cannot do by themselves. So to wrap it up, generative music should extend what's musically possible, at least like this is my philosophy. It shouldn't replace what humans can do already and screw them over. But I'm afraid that there's somebody who may not agree with me. And we'll see how it goes. That's cool, guys. That was it. So questions, comments?